In this video, I want to go over the reference sheet for trigonometry that we have that's going to show you all of the identities that I talked about earlier, and it will also tell us a couple of other fancy things about these functions. There's one other thing that I want to cover first, and that is the definition of what it means to be an even or an odd function. So let's take a look at that. So the definition of an even function is it's a function where f of negative x is equal to f of x. We'll see why these are called even and odd functions in just a minute. So for instance, if I look at the graph of y equals x squared, and I wanted to know what the y value at a negative value of x was, I would just need to look at the value of the positive value of x. And so you can see that even functions can be reflected across the y-axis. And so there is, a vertical symmetry there. With odd functions, we have a slightly different situation. So here an f of negative x is equal to negative f of x. So for instance, if I'm looking at the graph of y equals x cubed, and I wanted to know what the value was for some negative input value, I could figure out what it was for the positive input value and then just flip the sign of that. So odd functions don't have vertical symmetry, but it does have 180-degree rotational symmetry about the origin. So if I spun this graph around by 180 degrees, it would look the same as it did before. The reason these are called even and odd functions, I think, at least this is a trick that helps me remember what they mean, is that if you're dealing with simple polynomial functions, like x squared or x to the fourth or x to the 18th, these are all even functions. And for odd functions, you're thinking about functions where the exponent is odd, like x to the third power or x to the 575th power, or in fact, just simply y equals x is an odd function because it has 180-degree rotational symmetry about the origin. All right, so that's even and odd functions. So let's take a look at our laws and identity page. And you can see here how there's a lot of the big keys that we talked about in the last couple videos. So we've got the two tangent identities. Tangent is equal to sine over cosine, and cotangent is equal to cosine over sine. Here are the 6 reciprocal identities, which are also very handy to know. There are actually 3 Pythagorean identities, but you really only need to know the first one. And in fact, you might not even be quizzed on the first one. We might just use it during a video. One thing you'll see is that graphs are periodic. All of these things are periodic. Sine, cosine, cosecant, and secant have a period of 2 pi, which means the graphs repeat themselves. You don't need to remember that. The law of cosines and the law of sines, we don't need to study. These are useful things in Algebra 2 or maybe advanced algebra, if you ever got around to that. The double angle and half angle formulas, once again, good to know if you are a carpenter, not all that useful for us in calculus. What you can see from this table about the even and odd identities, and this will be clearer when we're looking at the graphs, is that cosine and secant are even functions, and the other 4 trig identities are all odd functions. And then down here, we get even a little bit zanier. So product to sum identities, sum to product identities, the law of tangents, cofunction identities. This is a little bit interesting. This just says that all of the graphs are kind of phase shifts of each other. So that's the difference. That's the relationship between sine and cosine, between secant and cosecant, and so on. Mile-Wide's formula, I had never heard of this thing literally before I looked at this video, this sheet of paper, and it's not all that important. The sum and difference identities, we will actually use the sum of the sine function very soon, but you don't need to memorize this. You just need to remember that somebody has worked this out, and we will take their word for it. All right, so that is a quick overview of the trigonometry laws and identities reference sheet. Some of those things are going to be very useful if you memorize them. The tangent identities and the reciprocal identities being the foremost among them. But the other things are kind of nice. We'll get a quick overview of them when we look at the graphs of these functions, though.